Welcome back students to one more session of your WOC. Right, so today the topic which we are going to discuss is electron dot structure of the different, by sharing we are going to see the electron dot structure of different examples. So in the previous video I have taught the introduction, I have taught what actually is the carbon, what are the uses, then I have taught bonding in carbon. Today the topic, take your pen and write, we'll be learning electron dot structures. Okay, ma'am, electron dot structures of different examples. Let us see. So here we'll be taking the examples of hydrogen, we'll be taking the examples of chlorine, we'll be taking the examples of nitrogen, we'll be taking ammonia, methane, and later in the videos I'll be teaching ethane, like that, a lot of examples I'll be teaching. Right. So here when you draw the electron dot structure, first important thing you need to remember, you need to know the atomic numbers. Remember that without atomic numbers nothing is possible. Basically in your grade 10 try to learn the atomic numbers from 1 to 30. It's okay, 1 to 30. Why ma'am? Why, how 30? Nothing, it's easy. Basically 20 everybody can learn, little learn 1 to 30, it will be useful in your grade 11th also. Right. So here in dot structures, let us take first example of hydrogen. Right. Here hydrogen atom, as I said, how many are there? 2 atoms are there. So one hydrogen, atomic number 1. So divide K, L, M and N. So only one electron, it is there in K. One more hydrogen, because 2 hydrogens, no? One more hydrogen is there, 1. Now these two together, this will share with this will share with this. When both share together, they'll form a covalent bond, correct? So basically how hydrogen looks like, see here, this is the nucleus, this is the K shell, this is the L shell, okay, M and N. So how many electrons? There are only 1 electron here. Now here what happens, one hydrogen, first you are going to write one hydrogen, you are going to write one more hydrogen, little bit closer we will write one hydrogen. So draw one circle for this, you will overlap one more circle because this is a covalent bond. So this hydrogen is going to share, one electron and put a cross. This hydrogen is going to share, this is the second hydrogen, this is the first hydrogen, this is the second hydrogen. This is going to share one more and take it. Now they are attaining 2 electrons. 2 electrons means it is stable configuration, that is helium. So whichever element tries to share, they combine to get inert gas configuration. Means inert means stable configuration. So this configuration is compared to helium, atomic number 2, K, L, M, N, 2. So here also 2, here also 2. Now how many are there? You will try to join this bond like this. So when you join the bond, how do you get? One hydrogen with single bond. Only one, no? One electron. Here one electron. So the structure of hydrogen is HH. That's why it is H2. Done? Yes. So this is the basic idea. I think hydrogen you have understood. Now let us do one more. You will understand gradually. Now let us take the next example of chlorine. Now chlorine atom, as I said, you need to know the atomic numbers. Without atomic numbers, and atomic number will not be given to you, remember. So chlorine atomic number, chlorine formula is Cl2. Chlorine atomic number 17, K, L, M, N. 2, 8. K always can accommodate only 2 electrons. L can accommodate 8. M can accommodate 18. N can accommodate 32 electrons. So how many? 2, 8. 10 are over. How many are left? 7 are left. How many it requires? It requires only 1 electron to become stable. When it acquires 1 electron, what will happen? It will get stable configuration. Let's see. So first thing, this is the example. Second thing, you need to write this. Third thing, you need to take chlorine atom and make one circle. Right? Now 2 Cl's are there. Take one more chlorine atom, make one more circle. How many electrons it requires, or how many, what is do? Only 1, isn't it? So only 1 electron. This also only 1 electron over. This and this is joint. Now when you are after writing this, take your pen, don't join it. For your understanding I'm saying, leave it like that in the exam. After that, you need to mention the remaining electrons in that. Why? Then only we can say whether it is stable or not. Now see, 1, 2, 3, 4. Write it in sets. 1, 2, 3, 4, 5, 6, 7. It's okay. Above or below. Now 1, okay, let us see. 1, 2, 3, 4, 5, 6, 7. I have to write 8. One more. Now count. Total should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Done. For this also. 1, 2, 3, 4, 5, 6, 7, 8. So this also has got 8 here. This also has got 8 here. Don't think about this. This is over. Nothing to do. We are talking about this. So one chlorine has given shared 1 electron, 1. This also has shared 1 more, so 2. So what is a bond? It is only single bond. So chlorine dash chlorine, that is nothing but Cl2. So single bond is the concept now. Right. Let us come and see one more example. So let us come and take the third example, that is nitrogen. Right. So here in nitrogen, again same story. What should you do? You need to write the atomic number. So let us write the atomic number. Nitrogen atomic number is 7. How many are there? 2 nitrogens. So nitrogen 7, KLMN. 2 and 5. 5 plus 2 is 7. Correct? No? Yes. Some students will write 2, 3 and 2. This is wrong. Why? Because L can accommodate maximum to 8 electrons. Till 8 it can fill its stomach. K can accommodate 2. M can accommodate 18. This can accommodate till 32 electrons you can fit. Right. So how many it requires to become stable? It requires 3 electrons. With 3 only, then only it will become stable. If it takes 3 electrons, automatically it will get inert gas configuration. This will become 8. Always remember, 3 it takes. Always your concept is this should become 8 or this should become 8. That's it. Now how many nitrogens are there? 2 are there. Let us draw. 1 nitrogen is here. Draw one circle. 1 more nitrogen is here. 1 more covalent sharing. Done. How many electrons? It requires 3 electrons, isn't it? 3. So 1, 2, 3. This side. How many this requires? 1, 2, 3. Done? Clear? Okay. Now, you need to count for this nitrogen. You need to count whole because both it is shared among both. 1, 2, 3, 4, 5, 6, 7 and 8. It should be 7 and 8. Done. You can write here also. No problem. Here also this side. 6 are there. 7 and 8. Done. So how many bonds are there? If I have to count 1, 2, 3. 3 bonds are there. Correct students? 3. So how will I write? Nitrogen triple bond N. That's why nitrogen is always triple bond. So N2 is a molecule. What is the type of bond here? It is nothing but triple bond. Shall we write for oxygen also? Let us see that also. Triple bond. Okay. Hydrogen, which type of bond was it? It was a single bond. Single bond. Chlorine was which bond? Single bond. Nitrogen is which bond now? It is triple bond. Correct. Now let us see oxygen now. Let us take this example out and write for oxygen. So oxygen, as I said, atomic number, same story. I need to remember the atomic number. So oxygen is 8. How do you divide? KLMN. 2 and 6. Over? Yes. Now, how many electrons does it require? It requires 2 electrons. It requires 2 electrons to become stable because total should be 8, isn't it? So 8 is the thing. How many electrons? Right, now let us come and see the electron dot structure of oxygen. Right, what did we write? Atomic number 8 we have written, 2, 6 we have divided, and 2 electrons it requires to become stable. Right, so we are going to write oxygen, make one circle around that, 1 more oxygen, make 1 more circle here. So 1 oxygen, how many it requires? 2 electrons, a little bit I'll make. So 1 and 2 for this side. This oxygen, 1 and 2 over. Now after writing that, remaining electrons also you need to mention. So how many are over? Total should be 8. The concept is it should have octet or duplet. For hydrogen we got duplet. For hydrogen we got how many like this? We got 2 electrons, isn't it? Here duplet. Here it is octet. Now count 1, 2, 3, 4, 5, 6, 7, 8. Then same story. 4, 1, 2, 3, 4 plus 4. Now how many bonds are there? Join this bond, oxygen, double bond, oxygen, O2. That's why the bond type of bond formed is double bond in oxygen. Here all single bonds, here double bond. Now let us come and do ammonia. Right. Let us erase this and take that example. Ammonia, NH3 is a formula. So NH3, what is the name? Ammonia. Ammonia. Right. Now ma'am, I have 2 atoms. Which one to take? Electronic configuration, right? For both you need to take, let us write, nitrogen is here, 1 hydrogen, 1 more hydrogen, 1 more hydrogen. Atomic number of nitrogen 7, atomic number of hydrogen 1, 1, 1. Divide K, L, M and N. Here also K, L, M and N. Only K is filled. K can always have 2 electrons. Done. Out of 7, 2 are gone. How many are left? 5. Hydrogen 1, 1, 1. More than that, no electrons. Now, to become stable, how many it requires? It requires 3 electrons, isn't it? It requires 3 electrons. Who will give this 3 electrons? Hydrogen is going to give. How it gives? Nitrogen is here. Hydrogen, hydrogen, hydrogen. This is the form. They all form 1 bond. Now I have to draw the structure of this. See, already 3 electrons are gone. Come now. Let us see. Nitrogen, you will draw it like this. 1 hydrogen is here. 1 more hydrogen is here. 1 more hydrogen is here. H, H, H. Done. Let us write. Now nitrogen requires 3 electrons. This will give 1 electron to this. This will also share 1 electron. This nitrogen will give 1 electron. This will also share. This nitrogen will give 1 electron. This will also share. So together there is single bond, single bond, single bond. Don't join in the exam. You need to keep it separately only. Outside you need to write the bond. Now exactly, are we not getting this? Yes, isn't it? So N, single bond, H, H and H. Simple. Now I need to write the number of remaining electrons in nitrogen. 1, 2, 3, 4, 5, 6, 7 and 8. Always 8 you need to show. Ma'am, for hydrogen also 8? No, it requires only 2 electrons to become stable. So this 2 counts for this hydrogen, this 2 counts for this hydrogen, this 2 counts for this hydrogen. So ammonia, which type of bond it forms? It forms a single bond. Over. Let us write the structure for methane, CH4. Right. So I'll be writing the structure for methane, ethane and C2H6 also we'll try to write in this video. Right. So here example, when I take CH4, the formula or the name is methane, an alkane. Right, again same story. I need to write the atomic numbers. Carbon is here. Hydrogen, how many hydrogens? 4 hydrogens are there. For everything atomic number is 1 only. So if you write 1, it's enough. So here atomic number 6. Divide KLMN. Here hydrogen KLMN. You can divide 2, always can have accommodate 2 electrons. L can take 4. Hydrogen 1 only. Now, how many carbon requires? Carbon requires 4 electrons to become stable because this should be 8 always. Count is 8. So, 4 electrons. Let us take. Now, 1 carbon, right? Now, how many are there? 4 hydrogens are there, CH4. 1 hydrogen, 1 more hydrogen, 1 more hydrogen, 1 more hydrogen. H, capital H, capital H, capital H, capital H. Now, 4 are there here, no? So what it does? This carbon shares 1, hydrogen also shares 1. Same story here also, same story here, same story here. Correct? Right. Now, if I have to write how many single bonds? CH4, 1, 2, 3, 4. Ma'am, you draw the structure like this. Okay, shall we write like this? Okay, not to confuse you all, we will write like that so that you will not get confused. So same thing, carbon, so one circle, one circle, one circle, one more, H, 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 single, 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 single. This is not confusing you now? Yes. So finally, methane structure is CH4. This is done. What type of bonds are there? All are single bonds. Simple, students, easy. Right. So I think with this we have covered. Let us come and see C2H2 now. Let us draw the same C2H2 also. Same thing. Easy it is. Only thing I need to remember, atomic number. So C2H2, the bond is C double bond H2. Why did I write double bond? Because the valency of carbon is 4. 2, 3, 4. 2, 3, 4. Right? Always carbon has 4 bonds. Right. How will I write? C2H4. So for one carbon, one circle. For one more carbon, one more circle. How many hydrogens are there? There are, for this carbon, 2 are attached. 1, 2. For this carbon, 2 are attached. 1, 2. Write hydrogen, 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 hydrogen. Done. Now, carbon atomic number 6, 2, 4. So, it requires how many electrons? 4 electrons. Done. See here, hydrogen is coming and providing, isn't it? So, this shares 1, this also shares 1, this also same, this shares 1, this also shares. So, if 1 is shared, 1 also will be shared. If carbon is sharing 1, this will not share 2. Remember that. So, here 1, here 1. Done. Now, important thing. Already 1, 2, 3, 4 are over here, no? Yes. How many more it requires to become stable? 8. So, see here, 1, 2, 3, 4, 5, 6. This shares. This also shares 2, 7, 8. Now, let us count it. 1, 2, 3, 4, 5, 6, 7, 8. For this carbon, 4, 5, 6, 7, 8. Simple. How many bonds are there now? C double bond C, H2, H2. See here, same thing I have got. The formula is C2H2. Ethene. Let us write. This is nothing but ethene. Now, shall we write? Now, what is the type of bond here in ethene? It is double bond. Now, let us write C2H6 now. Right. Let us take this and C2H6. Now, easy, isn't it? You can only write C2H6, C2H6. Okay, it is carbon, carbon 2. For this hydrogen 3 are there. For this hydrogen 3 are there. What bond will be there? It will be only single bond. Why? Because carbon forms tetravalency. It has only means it will have only valency of 4. We have seen in the earlier video. So single bond. 3 plus 1 4 for this carbon. 3 plus 1 4 for this carbon. Now let us draw. One carbon atom is here. One more carbon atom sharing, right? One hydrogen, two hydrogens, three hydrogens, one hydrogen, two hydrogen, three hydrogens. H, don't overlap these two. The lobes will be overlapped, but here to show you. H, 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 H. Right. Now, see here. Carbon, atomic number 6, 2, 4. Correct? Right. So, how many carbons are there? 2 carbons. So, for one carbon, this one. For one more carbon, one more. Same 2, 6. Hydrogen, 1. KLM shells, 1. Done. Now, it requires 1 electron. This requires 4 electrons. Now, let us write hydrogens and then we'll divide. one hydrogen, one, because only one electron it can share, no? So one electron. If this shares one electron, this also will share one electron only. Done. All carbons are over, hydrogens are over, all one over. Now I have to count total number of electrons. Here also I need to write. Now count 1, 2, 3, 4, 5, 6, 7. This will give 1, 8. Vertically I have written, correct? Right. Now let us count for this. 2, 4, 6, 8. Perfect. What is the type of bond? Single bond. Or how will I write? C, single bond, C. See here, C, single bond, C. How many hydrogens are there? 1, 2, 3, H, H, H. Done. For this carbon, 1, 2, 3, H. So C2H6, what is the type of bond we have? We have single bond. So I have taken a lot of examples here. So this is the structure, electron dot structures. So basically electron dot structure, if I have to say, ma'am, is this electron dot structure? There's one small, understanding in this concept. In my next video, I'll explain what is covalent bond, why we are writing electron dot structures, what is Lewis dot structure. Let us discuss in the next video. So thank you for watching. Signing off. I'll meet you in the next very important video.